This is a large topic, and I actually have slides on most of the trials. I don't have a detailed slide on every trial. I'm not going to go through every single slide. I'm going to touch the high points about what I think is important, and I will leave it to you if you want to look at the details in all the slides. But don't get hung up if I move off of a slide before you've had a chance to read the whole thing, because there's information there that's sort of background that some people may be interested in. Okay, so I'm going to talk about 5 things. I'm going to talk about current TB treatment and its theoretical basis. I'll do that briefly. I think most of you all probably understand that, but it is a background for where we're going. Then I'll talk about some of the new and the repurposed drugs. Again, you will have heard about these, but I want to give you a little bit of the evidence because they then come into the trials that we're doing. Then I'll talk about what we want to do with clinical trials, what our goals are, and I'm going to talk about trials for drug-susceptible TB, trials for drug-resistant TB, and trials for preventive, what we used to call preventive therapy or treatment of latent TB infection. Somebody said recently we shouldn't call it latent TB infection. We should call it labile TB infection because it's like ready to explode, and that I think is the way we should think about it. But at any rate, and then lastly, I'll talk about some trials that are currently being planned, very exciting trials, which we hope will move forward, although one never knows whether one's going to get funded. But eventually, good trials do seem to get going. So, nothing happened. Oh, we get a problem. We're stuck on the outline. Green. Ah, there it is. Okay. So this is our schematic diagram of what we think is going on in TB. That at the beginning, there's a very high burden of organisms. Let's see. There's a point. There's a very high burden of organisms. We treat with a whole bunch of drugs, and we try to drive that down really fast, and we call that the induction phase. And then what happens is that once we drive it down pretty fast, the bugs stop decreasing, and what happens is you replace the actively replicating ones with the non-replicating ones, and you have a long second phase, and we call that the continuation phase. Now, we didn't actually have this theory in mind when we developed current treatment. We actually developed treatment and discovered that by giving a lot of drugs at the beginning, and then you didn't have to give all those drugs, you could give fewer drugs here, and so we called this bactericidal activity, and we called this sterilizing activity. We don't actually know what those mean. It could mean that there are differences in the bugs. That's what this slide shows, that they go from blue to red, or more real. All bacteria actually do this, even E. coli and strep do this, but the antibiotics we have seem to kill them off equally. But in TB, there seems to be a difference, and so that we find that sometimes we need different drugs for this phase and for this phase. We also use a lot of drugs at the beginning to try to prevent the emergence of resistance, and that causes a lot of toxicity, so we like to back off. Whatever reason it is, we do this sort of bipartite therapy. And I think the reason for this is pretty clear. Because TB is a slowly replicating bug, it's a long course of therapy. It's not 2 days followed by 4 days. It's 2 months followed by 4 months for drug-susceptible TB. And for drug-resistant TB, it's 8 months followed by anywhere from 12 to 16 months. So it's a long course of therapy. I do think this is actually because the bugs replicate slowly, because most of the antibiotics work by inhibiting particularly cell wall synthesis. And if they're not replicating, they're not making cell walls, then the antibiotics don't work so well. But the other possibility is that the antibiotics just aren't getting to where we need them. So we're not really sure if the differences between induction phase and continuation phase are due to the antibiotics and the way they interact with the bug, or if they're due to the antibiotics and the way that they get into the lesions where the bugs are. Because what happens here is not only are these bugs non-replicating, but they're usually walled up in granulomas, and some antibiotics don't get into granulomas very well. This is an ongoing area of research. I can't say as I have the answers. There's a sort of 2 competing theories, both of which may be partially right. But we are left with the idea that we probably still need to do TB therapy with an induction phase and a continuation phase. Okay, so the goals of treatment trials if we're going to do them, are going to be many. We want to shorten the duration of treatment and increase the proportion that are cured, and those sort of work against each other, but that would be our goal. We'd like to decrease the amount of relapses that we see and minimize the emergence of resistance. Another thing that we'd like to do for some of the newer drugs is optimize the dosing. We don't actually know. We really don't know what the right doses are, so we're going to try to optimize the doses, and some clinical trials are going to address that. We'd like to minimize the adverse drug reactions because basically all of us in TB are in the business of creating work for people that study hepatotoxicity, and so we'd like to not be doing that. And then, of course, because many of our patients have HIV, we need to maximize compatibility with antiretrovirals and other adverse drug reactions. If you're taking birth control pills, our treatment isn't very good for you. And then we'd like to, lastly, at the bottom, be able to also to prevent progression from infection to disease. As I said, I will talk about that at the end. Oh, okay, well, wait a minute. See if I can go back. Okay, so I'm going to talk about new drugs and what we call repurposed drugs, which are old drugs that we've had for a long time we haven't been using for TB treatment. Because we haven't been using them, the bugs aren't resistant, and they're very useful, particularly for MDR-TB. So this is the global TB drug pipeline, and this is a slide that I'm very happy to have because the previous version of this slide was one that had a big gap. It had a big gap here in the early preclinical development, and I'm happy to say we now have some newer drugs, all of which have numbers, which tells you something. It means you're not going to hear about them anytime soon because they're really in the very early stages of development. But we have some, and this is phase 1 is when they're first studied in man, just to see that they don't knock people off without even doing anything else. And this one is actually in its phase 1 safety trial. So these are the clinical trials. My talk today is not going to talk much about phase 1 clinical trials, partly because there aren't many in phase 1, although a couple of these are about to move forward, but also because there's a lot of drugs that go into phase 1, and we estimate only 1 in 20 makes it into a useful drug. So you don't really need to hear about those, but you do want to know that there's a big group here, and there's even more out here. So this is good because we still do need more drugs. Most of what I talk about is what can we do with the drugs we have, but we clearly would like to have new drugs, ones that work better, ones that penetrate better into granulomatosis, etc. So hopefully some of these will be in that category. So now phase 2 and phase 3 clinical trials is really what we're going to focus on. Phase 2 clinical trials are when you're doing dose finding, and or you're looking to see if the drug doesn't have pharmacokinetic problems, it doesn't interact with other drugs. There's a lot of studies that we do prior to actually doing a full-fledged clinical trial. And so the phase 2 studies, and there are a number of them, these drugs are all in phase 2 studies, and I'll talk specifically about each drug in a minute. And then phase 3 studies are full-scale clinical trials meant to demonstrate that a particular drug used a particular way with particular other drugs and certain kind of schedule is effective at curing TB and hopefully making an improvement over what we currently have for TB therapy. Okay, so these are the new drugs that are in phase 2 and 3 clinical development at the current time, and they are Rifapentine, which I think you probably all know is a rifamycin very similar to rifampin, Moxifloxacin or fluoroquinolone. But then these drugs, Bedaquiline, Delaminid, Pretomanid, and hopefully Sutezolid, are new drug classes. Bedaquiline is a drug all by itself, and as you know, it is out there. We can use it, but really we don't know how to use it best. And so there's a number of trials that are going to hopefully help us know how to use it best, and also see if some of the potential toxicities really are real. There are some issues there, and I'll talk about them. Delaminid and Pretomanid are two drugs that are very similar. They cross-react. So they're a new drug class, but the two together are one class. They don't give us two new drugs, because if you're resistant to delamanid, you're probably going to be resistant to Pretomanid and vice versa. They are both in some phase 3 trials, which I'll talk about. The last one, Sutezolid, is an oxazolidinone. That's Linezolid is another oxazolidinone, which we currently have and we use mostly for treating for staph, but you know that we're now using it for TB as well. Sutezolid is a drug which was invented at the same time as Linezolid, but Linezolid was going to make money for the company, so they moved it forward. Both of them were invented in 1993. Linezolid's been on the market for about 10 years, and Sutezolid isn't on the market yet, because it was more effective against TB than Linezolid was in the test tube, but that meant that there wasn't any commercial potential, so it just sat there. Finally, it started to move forward. Pfizer was developing it. They then they did some early work, which I'll show you. They then backed out of the business. They gave it to Sequela, who has been struggling to get some trials going. And just recently, this drug was also given to the medicine's patent pool. So it is now available for other people to study. And I understand that there are some other groups that are going to start studying it soon. We hope that will happen. Our goal, we really hope that this drug turns out to be as effective as Linezolid without some of the toxicities. I honestly can't tell you whether I think that's going to happen. It's really never been studied for more than 2 weeks in people. So Linezolid looks good in 2 weeks too. So the jury's out, and somebody has to study it and find out whether it's any better. We hope it is. Okay, so Bedaquiline, as I mentioned, is a new class of drug. It's a diarylquinolone. You know, you don't need to, we won't test you on that. But it does have a different mode of action. It inhibits the proton pump for ATP synthase in mycobacteria, which is a totally different way of working, although it turns out that our old friend Clofazimine may work in a similar way. But it has very little nausea. It's pretty well tolerated, but it does have this problem with QT prolongation, and this has led to kind of a slowing of its development because there are a number of studies which are trying to find out how serious a problem that really is. This is the study, the first study that was done. This is an MDR-TB study with Bedaquiline, where Bedaquiline was added to a background regimen. So these people all got a background regimen plus Bedaquiline, and these people all got a background regimen plus placebo. And you can see this group converted its sputum much more quickly than this group. And these were all patients with MDR-TB, so the sputum conversion isn't so great, but the Bedaquiline clearly had a beneficial effect. And when they followed people out over a long period of time, they found that not only was the median culture conversion much shorter in the Bedaquiline group than in the placebo group, but the number of people who were cured at week 120 was 58% versus 32%, a pretty lousy outcome here, but it was a lousy background regimen. And the serious adverse events were equal and probably not related. It didn't look like Bedaquiline was causing any more serious adverse events. One of the problems, however, was, I'll go back, was that there was a statistically significant increase in the number of deaths after 120 weeks in the Bedaquiline group. Most people think this is due to chance, but the FDA wasn't willing to sort of accept opinion for that, so there's a black box warning on the drug, and there is a trial currently going on, which I'll talk about later, to try to see whether this is really true. There are some observational studies from South Africa suggesting it's not true, but this is a group of patients, all of whom have a lot of different reasons for mortality, so it's been very difficult to tease out. And at the moment, the drug still has the black box warning. Delamanid is another drug which used to be called OPC. They always used to have a number, and when they start to get a name, you know something might really be happening. So this one is, as I said, another new class of drug, nitramidazole. It works against mycolic acid synthesis, which is a cell wall. So this is a cell wall active agent. Unfortunately, it also has some QT prolongation. The nausea is pretty mild. So both of these drugs are relatively well tolerated for TB drugs, but the QT prolongation is an issue. And it is, so like Bedaquiline, there is a certain amount of QT prolongation. QT prolongation itself is asymptomatic, and as long as it doesn't get too long and lead to arrhythmias, it's not a problem. And we don't see a lot of sudden death, but of course we don't want to see a lot of sudden death, and therefore we get nervous about this. But to date, there has been a fair bit of QT prolongation and no detectable sudden death. Of course, that's what the FDA was worried about when people die later on, but most of them, the bedaquiline was probably out of their system at the time. So Delaminid also has done a phase 2 study in which they added Delaminid at 2 different doses to optimized background therapy in patients with MDR-TB, and this was as successful in the sense that the patients who got Delaminid at either dose had a higher rate of culture conversion. It was only given for 2 months, and so there is, I don't know what LAMP2 error means, but at any rate, this drug has also been approved by the WHO for use in MDR-TB, again, with even less data than the bedaquiline, but there is enough data on patients who have taken it for 6 months to say that it doesn't seem to have serious toxicities other than the QT problem. So this is also a drug which we have available for use in MDR-TB, but it really hasn't moved forward for drug-susceptible TB yet, but there are some trials that may move it in that direction. Pretomanid is the other drug of this class, and this one is also, of course, a mycolic acid synthesis inhibitor. It doesn't seem to have the QT prolongation, and that has made it, an attractive drug to pair with bedaquiline, and we'll see some studies coming up in which that combination is being looked at. These are the data for Pretomanid. This is being developed by the Global Alliance, and so they're actually trying to develop it along with other drugs as part of a combination and not looking at just the drug itself. You saw the bedaquiline and the Delaminid both did studies where they just tried to isolate the effect of their drug, because that's what drug companies do. They want to see that their drug is effective so that the FDA will license it. The Alliance is not really looking to license Pretomanid by itself. They're looking to develop regimens, and in this regimen, Pretomanid plus Moxi plus PZA showed that and this is the green line here, and the green line and the pink line all had two different doses, were both more effective than HRZE, our standard regimen in drug-susceptible TB, at converting the sputum. And so it does look like a reasonable regimen, and it would be a rifampin-free regimen, so this has some advantages. And they have moved forward with a trial of this regimen. Sutezolid, as I mentioned, it works like Linezolid, and it inhibits protein synthesis. And this is the study that Pfizer did before they got out of business, showing that if you this is a 14-day study, showing that you can decrease the colony counts of patients with TB, giving, this is an EBA study, they gave it by itself, and you can see that particularly, so this is our 4-drug regimen here, but Sutezolid did some, definitely reduce the colony counts over the first 2 weeks, and so it looks to be an effective drug. I don't think this is a surprise. Linezolid has a similar pattern. But, as I say, it's only been given for 14 days. And frankly, I don't think we even have a decision yet as to whether we could give it as a once-a-day drug, the red line, or a twice-a-day drug. It looks like twice a day is a little better, but, in terms of ease of use, once a day would obviously be a much preferable regimen. So that has not been studied, and hopefully now people will start studying that sort of thing. Clofazimine, an older drug now that we didn't use. I remember when I was in my training, long in the dark ages, we still had clofazimine because it's been around since the 50s. I haven't, but it has. And we used it for TB, and we didn't notice any effect. But we didn't probably use it on enough patients and look carefully, because this study done in China showed that when you added clofazimine, again, this is MDR-TB, and you added clofazimine to a background regimen, the purple dotted line is a background regimen alone, and the green line is the clofazimine added. You got quicker conversion of the sputum, and you got a higher proportion of treatment success in the clofazimine group. So it does look like clofazimine works. There have been some animal models showing it does seem to add something to treatment, and of course it's been added to a regimen, a 9-month regimen for TB, which you'll hear more about, for MDR-TB, which you'll hear more about in the talk that follows this one. So clofazimine seems to be effective, and we are including this, particularly for MDR-TB, because we don't have anything better to offer. But it seems to be an effective drug, and we kind of left it on the shelf for a long time. Linezolid, as I mentioned, has also been studied in TB, and this study was a study of patients with XDR-TB who were randomized to, they were already on background regimen, they hadn't converted their sputum, so these are people with really bad TB, and this group was given clofazimine right at the beginning, and this group was delayed for 2 months and then given, not clofazimine, Linezolid, added to their regimen. This group was delayed for 2 months and then started on Linezolid, and you can see both groups eventually converted their sputum. Patients who had been on treatment for 1 to 2 years and hadn't converted their sputum, addition of Linezolid was helpful, and in fact, in the long run, they got quite a few cures using Linezolid. So it was an effective drug, and we have now started to include it in our treatment. It is for MDR-TB. It is a relatively toxic drug, and there's a very narrow window between the most efficacious dose and the toxic dose. So it's difficult to use, and it's probably never going to become a very commonly used drug for TB in general, but it's certainly a useful drug for MDR-TB. This is Rifapentine, and this is just a graph showing that you can convert the sputum a little faster with Rifapentine, which is the purple line, than you can with standard dose of rifampin, which is the green line. Not a great difference, but an increase in sputum conversion all along the time course over the first 16 weeks of treatment. And as a result, people are looking at Rifapentine-based regimens, thinking that if it's actually a little more effective in the induction phase at being bactericidal, it may help us shorten treatment. And then lastly, our old friend Rifampicin has also been looked at higher doses, and the same thing is true, although it's a messy slide. The higher doses of rifampin at 30 and 35 milligrams per kilogram are the ones that are the lowest. So in this graph, and I apologize, people do these things differently, but this one, going down faster, is a more effective drug. And so the higher doses of rifampin were more effective than the standard doses, and this has led people to say, okay, we probably want to do some trials of rifampin at higher doses to see if we can get a better effect. So let's start with the phase 2 trials. There are a lot of them going on. The trials which are either going to try to optimize dosing or minimize drug-drug interactions and adverse effects. I've told you about a lot of drug interactions and adverse effects, and so we have to do some studies, and I will talk about most of these. I won't talk a lot about at the bottom are some pediatric trials to develop pediatric dosing for delaminated bedaquiline. That's self-evident, and it's good to know those trials are going on. So the first trial I want to talk about just briefly, this is an ACTG-sponsored trial in which they're looking at how valuable is INH and is it important? We know that INH is really active in the very beginning of therapy, specifically in the first 2 days, and so this trial is looking to randomize people to different treatment, where this is the standard regimen for all 14 days. Here they drop out the isoniazid at the end. Here they drop out the isoniazid at the end and the beginning. Here they change from isoniazid to moxifloxacin. They're going to see if they can get a better effect. This trial is completely enrolled. We should get some answers, and this might help us know if there's a better way to use isoniazid than we're currently using it. This trial is a trial which is looking at another drug that's been used without kind of understanding how it works, and that's higher doses of INH. So we use INH at the dose, and we know it works, but actually some of the mutations that INH, that TB can have, can be overcome by a higher dose, and this study is going to look at higher doses of isoniazid to see if we can actually get an effect in patients that have some of the isoniazid mutations, and therefore, if we just knew they had those mutations, we could add isoniazid at a higher dose, hopefully be reasonably well tolerated, and we could do better. So this is another of those instances, just like with rifampin. We picked a dose 40 years ago that worked, but a higher dose might work better, and the same is true for INH. The OptiQ study is another study that we're doing to answer the same question. Fluoroquinolones weren't developed for use in TB, and they've been used at the doses that we use them for staph and E. coli, and they seem to work okay, but nobody's actually looked to see if a higher dose would work better, and there's a lot of data suggesting it would. So this study is going to look at higher doses of levofloxacin up to twice the current dose, which are reasonably well tolerated, but we don't know if increasing the dose will help us get a faster time to sputum culture conversion. And this study will actually try to draw this line of the therapeutic effect. As we increase the dose, do we increase the number of patients that respond, and do we avoid getting into toxic effects? This is what you hope to see, that the therapeutic effect is down at these doses and the toxic effect is higher. If it doesn't work out, you find the toxic effects are, you get the toxic effects before you get the therapeutic effect, and so then we can't use that dose. But all of these are trials in which we're trying to optimize the doses of our drugs. And, you know, it wasn't done before because we got regimens that worked, but now we're trying to get regimens that work better. And I think it is an important goal of clinical trials, and there is a lot of work going on to try to optimize these doses. This trial, the ACTG 5356 trial, is looking at how we can optimize doses of linezolid. Linezolid is a drug where we know the toxic therapeutic ratio is very tight, and there are other ways you might be able to use linezolid. So this is the dose that most people use, 600 a day. This is twice that dose, which is better, but does lead to a lot of toxicity, 1,200 a day. And this is a 300 a day dose that some people are using, and the question is, you might not need as big a dose when you're combining it with other treatment. And this is a study in which they're going to combine it with optimized background therapy and delaminid and see maybe that's good enough and it would have a lot less toxicity. So this is an important study, and this will help us optimize the dose of linezolid. This study is not a dose-ranging study, but rather a study looking at drug-drug interactions, another important study that's currently enrolling. And this one is a study which is looking at bedaquiline and delaminid alone and together. Remember, I mentioned both drugs have a QT problem and prolong the QT interval, and we don't know if putting the two together will be additive, or maybe it'll be less than additive, or unfortunately it could be more than additive, and so it might not be a good idea to be using these drugs together. We just don't know. So this is a small study which is going to look at intensive PK and QT intervals and see whether we really can use these drugs together. Okay, so those are the sort of the phase 2 trial. I didn't mention there's another trial I just learned about yesterday in which it's an interesting trial. It's being done in Korea, and they're taking people with drug-susceptible TB, and they're going to add linezolid for either the first 2 weeks or the first 4 weeks to see if they can drive down the bacterial burden faster and see if that is an effective strategy. And thinking you can usually get away with linezolid for 2 weeks or 4 weeks, but not for longer. So that's their strategy. It's an interesting trial, and look forward to seeing how it comes out. So now we'll move on to phase 3 clinical trials. These are the trials that are actually might give us regimens that we could move with, and some of the stuff I just told you about in the phase 2 studies was actually going to be also addressed in some of these phase 3 studies. The goal here, since we have a 6-month regimen that can cure 95% of the people in 6 months with 95% of the relapse-free, we're going to try to do better than that. Either shorten treatment while continuing to have a 95% cure rate, or increase the cure rate. Well, it's hard to do better than 95%. So most of the focus has been on shortening treatment. And this is not, we're not just starting this business. There's a number of trials that have been done, 5 of them. In fact, Remox, Oflotub, Rifaquin, NIRT, and TBRU. These are 5 trials that were done to try to shorten the treatment using various strategies, mostly involving fluoroquinolones or rifapentine. But the bad news is that all of them were inferior. So you can see in the standard 6-month arm, you get a variable rate because the populations were somewhat different, but all pretty reasonably similar to what we get 95% cures. So the relapse rate was low, the failure and relapse rate. But in the 4-month arms that were studied in all those trials, it was considerably higher. and using the statistical criterion of non-inferiority, they were all inferior. So we're not going to see any of these regimens rolled out soon. That's just to say this is the bad news. The good news is people haven't given up on trying to get a 4-month regimen. So there are 5 trials that are currently going on looking at 4-month regimens. This one here is a trial being done in India by the National Institute of Tuberculosis, of Research in Tuberculosis, NIRT. And it's a study which, this is the standard arm here, and is comparing 2 4-month regimens in which we give standard therapy and add moxifloxacin for the entire duration, and here just 3 times a week, to see if this will allow us to have a successful 4-month regimen. This trial is fully enrolled. I hope we'll have some results in the next year or so, but we don't know. So this is potentially a 4-month regimen that will work. It's not that different from some of the other regimens, however, that didn't work. So I'm not sure I'm going to hold my breath on whether this one's going to come in with a non-inferior regimen. This trial is a trial being done by the TBTC Study 31, and the ACTG, and has a different name there. And this is a trial also looking at a 4-month regimen for drug-susceptible TB that is using Rifapentine instead of rifampicin. So this is the standard arm here, and these are the 4-month arms. 2 of them, one in which moxifloxacin is added to Rifapentine, and this one just the Rifapentine substitution. So again, this is a very large trial, 2,500 patients being done globally. It started to enroll. It's not going to be finished for a while. So, but on the other hand, it has a number of different substitutions that suggest that it might be a successful regimen, but we really won't know until the trial is done. The STAND trial is a trial using Pretomanid, and Pretomanid is called PA here. And this is the one I showed you, Pretomanid, moxifloxacin, and PZA, a 4-month regimen, and then a 6-month regimen. That's the one that we saw the phase 2 data. And this is the standard arm, HRZE. Unfortunately, this regimen has had some toxicity. The trial has been halted, and my understanding is it probably will not be restarted. I don't really know. I don't know if a final decision has been made, but it's been halted for quite a while, and I have a suspicion that it's not going to go forward. So it's good to know that this trial is out there, but I think we may not see results on this one. The Rifashort Trial is one that's just started, and this is a trial that's now looking at increased doses of rifampicin. So this is our standard dose here, 2 months of rifampicin at 600 and a 4-month follow-up. Now if we give it at 1,200 milligrams a day with only 2 months of continuation, also at the high dose, and then at an even higher dose, we might see an effective shorter regimen. This one, I think, has good promise because increased doses of rifampin are much more effective, and rifampin is an extremely effective drug both in induction and in continuation phase. So this might get us somewhere, and it'll be interesting to see. This is a large trial, not as big as the other one, as you can see, but it's also not going to be completed until 2019. So I don't think we'll be doing this anytime soon. The real question is, in general, will people tolerate these higher doses of rifampicin and to a degree that we can roll this out as a standard regimen? I don't know if that's going to happen. But the phase 2 trials did suggest that even the 1,800 milligram dose was reasonably well tolerated. And this has been studied by several groups in several different situations and seems to be a robust finding. So this is an interesting trial, but it has just started enrolling. And then lastly, the SHINE trial. I can't remember where all the acronyms come, but this is a trial for children. And it's very interesting. We don't have trials in children, but this takes advantage of the fact that children don't have the cavitary disease and the extensive disease that adults have, and therefore it is likely that a 4-month regimen might be able to cure children instead of 6, and so this is going to study just that. The standard arm here of 6 months and a 4-month of the same regimen, but just for 4 months, because the children are likely to be responding without disseminated TB to responding faster, and this trial is underway. It's going to be a while before we get an answer. I don't think we even know the rate at which they're enrolling, but it's going to be a very useful trial, which would shorten trial for children and make life a lot simpler for treating pediatric TB, which in many cases you don't have a confirmed diagnosis and therefore you're a little nervous about it. If we could do it in 4 months, we'd be very happy. Okay, so those are the trials that are out there now for drug-susceptible TB. There's a lot of work going on in the drug-resistant TB space for two reasons. One is we have such terrible treatment that we currently only get about a 65% relapse-free cure, and the other reason is, of course, that we have to treat people for 2 years. So if we could make progress on either of those fronts, that would be a real benefit for the patients. So there are 7 trials going on. This one I'll just mention briefly, the STREAM trial, and the STREAM trial in stage 1 is testing a 7-drug, 9-month regimen that's called the Modified Bangladesh Regimen. You'll hear about this in the next talk. The WHO has already endorsed this regimen for certain patient groups, and it becomes tricky to know when to use it. The STREAM trial is using it in all comers and comparing it to the standard regimen. So this will be a very valuable trial. It is completely enrolled. We should have answers by the end of this year. So this will be, and we certainly hope that it will confirm that this regimen is effective and non-toxic. We hope it will give us more information about exactly which patients it can be used in and whether there are certain patients we should avoid using it in. But it's an important regimen. You'll hear more about that coming up. The STREAM trial has now gone on to do a second study, the stage 2 study, and this is a study I mentioned where we're going to have a standard of care arm without bedaquiline, and then 2 bedaquiline-containing regimens, a 9-month regimen that has no injectable, and a 6-month regimen that has injectable and bedaquiline. These 2 regimens, assuming they work, would give us a 6-month and a 9-month regimen to treat MDR-TB, and hopefully we'll be able to confirm what many of us suspect, and that is that there is not an increased mortality associated with the use of bedaquiline, and we could get rid of the black box warning. But this trial isn't going to give us answers anytime soon either, probably 2019. It's just beginning to enroll, but it's a very important study. The next trial is a trial currently going on in South Africa that's doing a very similar thing. It's studying a bedaquiline-containing regimen with linezolid and the kitchen sink, and comparing it to the standard 20 to 24-month regimen with kanamycin, an injectable agent. This is being done entirely in South Africa. It's a small trial, but again, it's probably going to take a while before we get an answer. So it's good to have several different groups looking at these questions, and they're looking at it in slightly different ways. The STREAM trial is using a fixed regimen. This one is using sort of optimized background, whatever you can, and with a variable duration depending on how people respond. So those will both tell us how we can better use bedaquiline. The delaminid, there's also a confirmatory trial of delaminid in which the delaminid is being added to optimized background therapy at 2 different doses, but given for 6 months, and then followed by 18 months of optimized background therapy. So this will suffice to give really good data about delaminid. I don't think it's really going to give us a regimen that we're going to use, because we're not going to want to give delaminid for 6 months followed by 18 months of background therapy as a way to improve on the treatment of MDR-TB unless it's really, really effective. So we'll find out. This trial is already completely enrolled. We should have data by the end of this year. So that will help us understand better how to use delaminid. The MDR-END trial is another delaminid trial. There's a small trial being done in Korea in which they're going to give delaminid plus linezolid, levofloxacin, and PZA, a standardized regimen for 9 to 12 months compared to the standard of cure. This also won't give us the results for a while. Part of the problem here is when you're studying MDR-TB and comparing it to the standard regimen that takes 20 to 24 months, you can't do it. Even if you enrolled all the people in the first year, you're still going to be 3 years before you get answers. So and this trial is enrolling, but we're not going to have answers until 2019. The NICS-TB study is a very interesting study that it's just a small pilot study of a regimen that contains bedaquiline and Pretomanid and linezolid. It's a high dose of linezolid, so it was really designed to try to be effective in patients with XDR-TB. These are patients with XDR-TB that really don't have other options, and here they presumably haven't seen Bedaquiline, haven't seen Pretomanid, and haven't seen Linezolid, so 3 new drugs, for only 6 months. And this study has enrolled 73 people, but a preliminary report was given at the Union trial where they showed that although it's a fairly toxic regimen, they were able to have relapse-free cure in the large proportion of the 30 or so patients that they reported on, all of whom patients with XDR-TB otherwise would have a terrible outcome. So this is actually a very promising regimen, and the company is moving forward with plans to study it in a more effective way. There's no control arm here. They just basically, it's a salvage regimen, but it's worked very well. So that's exciting, and I think we will hear more about that. But this trial itself is, I call it a phase 2-3, because it's actually not going to give you enough information to say, okay, let's roll this regimen out. And as I said, the Alliance is working on a new trial to follow this one up. The TB-PRACTECAL trial is part of that effort to follow it up. So this is a regimen with Bedaquiline and Pretomanid and Linezolid and Moxifloxacin. And this trial is going to actually look at a couple of different regimens and then pick the best one and move it into a phase 3 trial. But this could be very valuable. It has begun, but it's going to take a while to finish. So also might give us a regimen that we can move forward, particularly useful for for XDR-TB patients and pre-XDR-TB patients. The NTB trial is another trial which is looking at combinations of various Bedaquiline, Linezolid, Clofazimine, a whole bunch of different regimens, all in 9 months. It's using a very interesting design whereby they're going to, during the trial, look at which arms are doing best and stop randomizing people to the arms that aren't doing so well. So it's an effort to use a new trial design to kind of focus in and be more efficient on getting answers, so we can hopefully get answers quickly, although, as you can see, we don't expect to have answers until 2021. So you just can't be that quick. It's part of the problem. But it's a very interesting trial design, and I'll talk some more about that. Some of the other trials that are being planned are also using innovative designs, which I think will help us. So lastly, or not lastly, but I now want to talk about briefly about clinical trials for prevention of TB. So this is treatment of latent or labile TB infection to try to do better than we're doing, and also to try to have some regimens that we can give for latent MDR. This is a trial which is completely enrolled, and this trial isn't, in a sense, breaking any new ground, but it actually will give us very valuable information. This is a trial comparing the 4-RIF regimen to the 9-INH regimen, and as you know, the CDC is sort of like waffling about whether they want to recommend this regimen because there aren't any data. Well, this study will give the data. We should have it later this year. Everybody expects it to work. I've been using this regimen for the last 4 years. I bet many of you have too, and yet, you know, it's like not recommended because it's not recommended as first line, and so this will help us hopefully get that recommendation. So my hat's off to Dick Menzies, who spearheaded this effort after getting tired of hearing about, well, it wasn't recommended because they didn't have the data. This trial is a very different kind of a trial. This trial is going to treat HIV-infected people with LTBI with 1 month of daily Rifapentine to see if it works. So a 4-week regimen. Well, this would be awesome. I don't know if it's going to work. I'd say it's high risk, high gain. It is also completely enrolled. We should hear about it later this year. There are some issues here. If it works in HIV-infected people, that doesn't necessarily mean it's going to work in HIV-uninfected people. But I suspect it will be followed up if it works. So this is sort of the other end of the spectrum. Let's try a really short regimen and see if we can get away with it. So we'll find out soon. There are 3 trials going on, 2 of which have started already. The TB, I think the TB Champ, no, it hasn't quite started. Well, it's supposed to have started a couple of months ago. I think they might have enrolled their first patient. The VQuin trial is currently enrolling, and the Phoenix trial hopefully will start next year. So TB Champ and VQuin are both studies looking at household contacts of MDR-TB, and they're both using fluoroquinolone regimens, levofloxacin. So I think these 2 together will be very useful in telling us if you have MDR-TB that course, MDR-TB that's quinolone susceptible, and can you treat the household context with 6 months of levofloxacin? This would be a real breakthrough because we have essentially nothing to offer, and a single arm of levofloxacin is pretty well tolerated. So this would give us regimens that will work. The Phoenix trial is going to study Delaminid and compare it to INH. These two are going to compare it to placebo. It has to do with the populations that are being studied. But this would give us a Delaminid regimen that we could give for 6 months. And this would presumably work for a context of XDR-TB and pre-XDR-TB. So a very important study. It's supposed to start at the end of this year. And so hopefully that will get rolling fairly soon. The ACTG and the Impact Networks are sponsoring that one. This one's being sponsored by the MRC, and this one by the Australian MRC. So those are three very important trials that will give us a lot better idea of whether we have some other options for treating latent TB. There are, interestingly, a couple of other trials are being done with vaccines. And this is a vaccine trial, in which they're looking at a population that has a high risk of TB, namely adolescents in South Africa. And they're giving them this vaccine, which is a modified BCG that has listeriolysin, which in theory makes it a more immunogenic vaccine. And they're going to basically take 2,000 adolescents and randomize them to the vaccine or placebo, and then see if they can have less infection in this population. And a similar trial is being done in Tanzania, where they're looking to see if a vaccine can prevent infection in teenagers in Tanzania. And so this study both of these studies are currently enrolling. And so this is exciting because we don't really have anything like this, and a vaccine that obviously would help us with TB control in general. Now I'll just switch to my final topic, and those are trials that are currently in the planning stages. There are 5 of them. 2 of them are vaccine trials, 2 of them are treatment trials, and 1 is a prevention trial. So let's just start with the treatment trials. And these are, the first one is the Truncate trial. Now you remember that this is our schematic of TB treatment. There's 2 things we're trying to do. We're trying to drive down the burden very quickly, and although that doesn't necessarily translate to shorter regimens, it certainly could, especially if we drove it way down. And then the other thing we're trying to do is to shorten this continuation phase. The Truncate trial is focused on really trying to drive this down as fast as possible. It's a study which is going to look at regimens for 2 to 3 months, treating TB for 2 to 3 months. Now, remember, if you look back at the old studies, our current regimen of our rifampin-based regimens do cure about half of the people in 2 to 3 months. It's the other half that we worry about. So this study is going to look at 5 drug combinations of using various drugs, and including in some cases Delaminid and Linezolid and Bedaquiline. It's not clear what the combinations are going to be, but they're going to try to use combinations that they think will really drive down the burden very quickly and hopefully be able to treat people for 2 or at most 3 months. And what they'll do is follow them really carefully and see if they fail, then they'll retreat them. But they think that some of these regimens may be able to do a much better job at treatment so this is ultra-short regimen. It's an innovative trial. It's also being done with an innovative design, and that's called the multi-arm, multi-stage design. So they're not just going to pick their best arm and study it against this standard. They're going to pick a whole bunch of different arms. Let's say they had 4 different arms, and they'll follow them along, and they'll have an interim analysis. And if the arms aren't doing very well, if they're not converting the sputum, then obviously they're not going to be effective. They'll drop those arms so that they'll move forward with, they hope, at least one that they'll completely enroll. And obviously if they don't work at all, then they'll won't move any of them forward. This design has been used once before and was very successful. And so it is an innovative way of being very effective and winnowing down many possibilities into one or 2 regimens that look promising for ultra-short course treatment. And so I think that will be very exciting. And I hope it will get started later this year, but not yet. Now, the DAZZLE trial is a trial that looks at the other end of treatment. This is a trial with a standard regimen of Delaminid, Linezolid, Levofloxacin, and PZA, and it's going to study the regimen at various durations, all compared to one control arm. So the question here is, how long do you need to treat to get your goal of, what if it's 95% cure without relapse? And this is because if you look at the way TB treatment goes, the longer treatment is, the higher the proportion of cures are. And so when you get out to 8 to 10 months, we know everybody's cured. And down here we know maybe only 40 to 50% are cured. So the question is, if we can draw this line, we can then say, okay, what we want to do is we want to get 90% cures. Well, then this is where we want to be, and that's how many months we have to treat. And it's actually a very efficient study design because it allows you to use all the information from all the different arms, since people are randomized to different arms. So this is a study that will directly address what is sterilizing activity. Now, it won't tell us what it really is. It'll just tell us how long we need to treat with that given regimen. But this will avoid the problem that we had with all those 4-month shortening regimens, because if you just pick one duration and you say, I'm going to test this duration, and you fail, you don't know anything about whether, maybe if you'd given it for 2 or 4 more weeks, it would have been fine. You don't know that. This kind of a design will reduce the amount of waste, and it'll give us the answer of, for that given regimen, how long do you actually need to treat to get your sterilizing activity. So just to sum up, I've given you a broad spectrum of TB clinical trials that are currently in the field, others that are being planned, but it's a very active space. There's a lot going on. It's a very exciting time to be doing this, and I got to tell you, like a number of you, I've been in TB a long time. We didn't have this opportunity. Now we have new drugs, new designs, old drugs that we had forgotten about, and the combination is giving us a lot of possibilities. We may be able to increase our treatment responses, particularly for MDR-TB. I'm not sure we're going to be able to increase them for drug-susceptible TB, but we certainly may be able to shorten treatment duration for MDR-TB and likely for drug-susceptible TB as well. We really need to know more about the tolerability of these new and repurposed agents, especially when you're using in combination, and their ability to be used with antiretrovirals, and we will get that information from the phase 3 trials. The phase 2 trials give us some idea, but the bigger phase 3 trials will really tell us, is this something we want to roll out on a population basis? And lastly, the TB vaccines, of which there are several, I didn't talk a lot about them, may have the ability to increase treatment success. In some cases, these vaccines are being given at the end of treatment to try to prevent relapses. And that actually is a very exciting possibility if it works, because then we wouldn't have to treat so long. We could treat shorter and then give a vaccine at the end to kind of stimulate the immune response and mop up the remaining bacteria. So a very exciting potential. None of those trials are actually out in the field yet, but they're coming, and there's 2 of them out there. And so I hope that we'll see them soon. So I'll stop at this point.